Kia ora and welcome to this video for Level 2 Probability Exam, Question 2 from the 2013 paper. This is quite long and I'm going to go through it very slowly using tables as well as the graphics calculator, so I'm going to split it into two videos. This is just the first part. We'll get through around half the question. Okay, so just before we take a look, just be really careful with these questions that you make sure you put your units in your answer always. So in this first question, it's all about blood pressure. So read it carefully. Okay, the units you're looking at here are millimetres of mercury, not millimetres and not kilograms or anything weird like that. Okay, so the first question, what proportion of the students chosen at random from Alice's school would be expected to have blood pressure between 113 millimetres of mercury and 120 milligrams of mercury? Okay, I'm not going to read every word of that question out, but you should be reading it very carefully before you start doing anything with your pen. Okay, so here is my x. X is the blood pressure reading, and we've got mu is equal to 113 mmHg. Sigma is equal to 10.3 mmHg. So we're looking for the probability that the blood pressure reading x is between 113 and 120. So if you've got a graphics calculator, this is a very straightforward problem. You can just put in the lower and upper values of 113 and 120. Okay, and you'll get an answer out for that. But as I said, I'm going to go through this for people who are working with tables. So we'll insert a new slide here. Okay, right, just letting that come up. And now off we go drawing our two graphs. So always draw your x graph directly above your z graph. So we know the mean of the standard normal is 0. The mean of x is 113. And we're looking for this probability in here, so we draw the matching picture down here. And our job first is to find the value of z. Right, so z here will be 120 minus 113 divided by 10.3. What that's really saying is how many standard deviations is 120 above the mean. Okay, so we're looking at this gap here and saying we're interested in the value 120 millimetres of mercury. That's 7 above the mean of 113. How many standard deviations does 7 units represent? So 7 divided by 10.3 is going to be roughly 2/3. But of course we put that in our calculator and we get an exact value, and it's 0.6796. So that's saying that 120 is 0.6796 standard deviations above the mean. Now this we can look up directly in our tables. The tables don't go to 4 decimal places, they go to 3. So we're looking now for the probability that z is between 0 and 0.680. Okay, so the first part of the table comes from looking down until we get to 0.6. Then we look across until we get to 8. That gives us the value for 0.68. Then we look at the third digit, and we would use the strange looking column off to the right of the table. But we don't have to worry about that because it's 0.680. So the value we find in our table is 0.2517. Now you're asked to give your answer as a proportion. So if you leave it as a decimal, you'll probably get it marked wrong. So as a proportion means you need to give it as a percentage or a fraction. So 25.17% of people or students have blood pressure between 113 and 120 millimetres of mercury. Okay, so now the only other thing there is do not round that down to 25%. Just be careful, try to stick with 4 significant figures most of the time when you're doing probability. If you are going to round, don't do any rounding until you're at the very, very end of the question. Okay, on to the next question. There are 719 students at Alice's school. How many would you expect to have blood pressure less than 115 mmHg? So we're looking for this area here is step 1 to find the probability. This is x, mu is 113. So you can do that directly on your graphics calculator. You're going to do a lower value of -999, an upper value of 115, mu of 113, and sigma of 10.3. Right, but if we're standardising, we're going to be looking for the z value, and that will be x minus mu over theta. So z is equal to x minus mu over theta, which is 115 minus 113 over 10.3. And again, the interpretation here is that we're saying this gap here of 2 is how many standard deviations. So we know that our answer will be around about 1/5, okay, about 2 over 10. So the exact number is 0.1942. Okay, that should be showing up now. So the probability that z is less than 0.1942, using the tables again, we get 2 parts to that answer. The first part is the 0.5 on the left-hand side, plus from the tables 0.0753, and then a little add factor of 16. Okay, so that works out to be 0.5769. But we haven't finished the question because we need to give an expected number of students. So the expected number is equal to 719 times 0.5769, which works out to be 414.79. You can round that either to 415 students, or they also accepted 414. Okay, next question. Getting a tiny bit harder, but still fairly easy. Probability that 2 randomly selected blood pressure readings are both over 110 mmHg. Okay, so again, here's my x. I'm first looking at the probability that one student's reading is greater than 110. So we're going to find p, x greater than 110. Right, graphics calculator, very easy. With the table, you're going to be looking for 2 regions. So here's my z. This side here is area 1, and that is going to be 0.5. Here I need to find my z value. So we have z equals 110 minus 113 divided by 10.3, which works out to be -0.29126. Because the curve is symmetric, I know that if I look up positive 0.29126 on the table, it's going to give me the correct answer. Okay, so looking that up in the table, I will get, for this probability, in here, right, I get 0.1141 and an add factor of 4, so that's 0.1145. So my probability works out to be, need some more room, it's getting a bit messy. Here comes the new slide. So probability that z is greater than -0.29126 is equal to 0.5 plus 0.1145. And that equals 0.6145. But we're asked about the probability that 2 students will have readings above 110 mmHg. So we need to take that probability and square it, which gives us 0.6145 squared, or 0.3776 0.3761. I think if you're doing that on the graphics calculator, you'll get 0.3776, which is fine. So that was a merit question. That's all I'm going to do in this first part of this video. I'll do the rest of the question in part 2.